The planet Kepler 442b hung in space like a massive blue-green marble, but this marble could crush a person flat if they were not careful. The gravity here pulled everything down with more than twice the force of Earth, making every step feel like walking through thick mud while carrying heavy bags. Dr. Lisa Hayes pressed her face against the small window of the transport ship, New Frontier, and watched the planet grow larger as they approached. She had studied the reports for months during the long journey from Earth. 3 years ago. Alien! Archaeologists had found something incredible buried deep in the canyon systems of this heavy world. The ruins belonged to a race called the Predecessors, being so advanced that they had vanished from the galaxy millions of years before any current civilization had learned to make fire. Hidden in these ruins was technology that could change everything, especially the way ships traveled between stars. The problem was simple enough to understand, but apparently impossible to solve. Deep in the largest canyon, 800 meters down from the surface, sat a crystalline core that weighed 50 tons. This crystal held the secrets the galaxy wanted, but getting it out of that deep hole had proven beyond the abilities of the most advanced species in known space. Lisa watched through the window as other ships floated near the planet. She could see vessels from the Zephyrian Empire, sleek and silver, their hulls glowing with the blue light of anti-gravity systems. The Construct Collective had sent their massive industrial ships, blocky and functional, designed for moving mountains and building space stations. Even the mysterious Luminar had come, their ships looking more like floating crystals than anything built by hands or machines. Captain Jake Morrison joined her at the window, his weathered face showing the kind of calm that came from years of military service. Behind him walked Pete Collins, their chief engineer, carrying a tablet covered with hand-drawn sketches and calculations. Amy Rodriguez, their physicist, followed close behind, already muttering numbers under her breath as she studied readings from the planet below. The docking procedure took longer than usual because of the planet's gravity. Even in orbit, everything felt heavier, and the ship's systems had to work harder to maintain position. When they finally connected to the orbital station, Lisa felt the artificial gravity shift and adjust, making her stomach lurch slightly. The station buzzed with activity from dozens of different species. Tall, thin Zephyrians floated past using personal anti-gravity belts, their movements graceful and flowing. Construct units moved in perfect formation, their mechanical bodies clicking and whirring with each step. Luminar representatives glowed softly as they drifted through the corridors, their energy-based forms shifting between solid and translucent states. What struck Lisa most was the mood. Despite all the advanced technology and brilliant minds gathered, here frustration hung in the air like a thick cloud. She overheard conversations in multiple languages, all centered on the same theme. 3 years of attempts, 3 years of failures, and no one seemed any closer to solving the problem than when they had started. The briefing room held representatives from 12 different species, each more technologically advanced than humans in their own particular way. Director Vex Thanner of the Hegemony stood at the front, his 4 arms gesturing as he spoke in the common galactic tongue. His words painted a picture of mounting desperation disguised as scientific curiosity. Dr. Zixandra of the Luminar had tried 17 different molecular manipulation techniques. Each attempt had failed when the crystal's unknown composition resisted their energy-based tools. She spoke in frustrated musical tones about quantum signatures that made no sense, and atomic structures that seemed to exist in multiple dimensions at once. Engineer Prime Thokvar of the Construct Collective had deployed progressively larger mechanical solutions. Their first mining robots had simply been crushed by the planet's gravity. Bigger robots had succeeded in reaching the crystal but could not generate enough lifting force to move it. The largest mechs had made it halfway up the canyon walls before their joints failed and they crashed back down. Adding to the growing pile of expensive wreckage at the bottom, the Zephyrians had perhaps come closest to success. Their anti-gravity technology was legendary throughout the galaxy, capable of making entire moons float like feathers. Master Engineer Velinux had personally overseen the deployment of their most powerful repulsion field generators. For a brief moment, the crystal had actually begun to rise. Then the generators had overloaded, the feedback destroying not only the equipment but also carving new cracks in the canyon walls. Lisa listened to each presentation with growing amazement. Not amazement at the failures, but at the approaches being taken. Every solution involved throwing more advanced technology at the problem. Bigger robots, stronger energy fields, more exotic manipulation techniques. It was like watching people try to open a door by building increasingly complex key-cutting machines instead of simply checking if the door was unlocked. Pete, Collins sketched quietly in his notebook throughout the briefing. Amy Rodriguez ran calculations on her tablet, occasionally shaking her head at what she saw. Jake Morrison studied the tactical displays showing the canyon system, his military mind automatically assessing terrain and structural possibilities. When the briefing ended, the human delegation remained seated while the other species filed out, their conversations a mixture of technical jargon and barely concealed frustration. Several aliens glanced at the humans with curiosity but little hope. After all, if the galaxy's most advanced civilizations could not solve this problem, what could a species that had only recently developed faster than light travel possibly contribute? Director Vex Thanner approached their table, his massive form casting a shadow over the humans. His translation device rendered his words in perfect English, though the underlying tone of polite dismissal came through clearly. He welcomed them to the project and offered the standard briefing materials, but his manner suggested he expected them to observe rather than participate. Lisa stood and asked a single question that seemed to surprise everyone within hearing range. She wanted to examine the canyon's geological structure, to study the rock formations and soil composition around the excavation site. The request prompted confused looks from the departing aliens. Why would anyone want to study rocks when the problem clearly required advanced technological solutions? That evening, as the New Frontiers crew settled into their temporary quarters on the station, Pete Collins spread his sketches across the table in their common room. Jake Morrison studied topographical maps of the canyon system while Amy Rodriguez reviewed the physics data from 3 years of failed attempts. The solution began to take shape not through advanced technology or exotic physics, but through simple questions that apparently no one had thought to ask. How much weight could the canyon walls actually support? What was the coefficient of friction for the local rock types? Were there natural anchor points that could handle significant stress loads? Lisa looked out the window at the planet below and smiled. Sometimes the simplest questions led to the most elegant solutions. The emergency session began at dawn station time, though on Kepler 442b the concept of dawn meant little in the deep canyons where artificial lights had replaced the sun 3 years ago. Representatives from 12 species gathered in the main conference chamber, their various forms of communication creating a symphony of clicks, musical tones, electronic bleeps, and translated speech. Director Vex Thanner stood before the massive holographic display showing the excavation site. The image rotated slowly, revealing every detail of the canyon system that had become both treasure vault and prison. His forearms moved in complex gestures as he spoke, the frustration clear in his voice despite the mechanical translation. Dr. Zixandra of the Luminar presented her latest failure first. Her energy-based form flickered between states as she described her most recent attempt at quantum deconstruction. The theory had been sound, she explained in her musical voice. By breaking the crystal down to its component atoms and reconstructing it at the surface, they could bypass the gravitational and structural problems entirely. The attempt had lasted exactly 47 seconds. The crystal's atomic structure had resisted every form of quantum manipulation the Luminar possessed. Worse, the feedback from the failed deconstruction had created a small explosion that had widened the bottom of the canyon by several meters and buried the crystal under additional debris. Engineer Prime Thokvar of the Construct Collective spoke. Next, his mechanical voice precise and emotionless. His latest solution had involved a swarm of smaller robots rather than a single large mech. The theory suggested that distributed lifting capacity would be more efficient than concentrated force. The robot swarm had performed flawlessly until the moment they attempted to lift the crystal. The combined weight of 50 tons plus the robots themselves had exceeded the load-bearing capacity of the canyon floor. The entire swarm had disappeared into a sinkhole that opened beneath them. Taking expensive equipment and 3 months of preparation with it, Master Engineer. The Lennox of the Zephyrians had tried a different approach entirely. Instead of fighting the gravity, they had attempted to create a localized gravity well that would pull the crystal upward. The mathematics had been elegant. The energy requirements massive but manageable. The gravitational anomaly had worked exactly as designed for nearly 5 minutes. The crystal had begun to rise, lifting steadily toward the surface. Then the planet's own gravitational field had interfered with the artificial well, creating a feedback loop that had torn apart not only the gravity generators but also several monitoring stations on the canyon rim. Species after species presented their failures, each more technologically sophisticated than the last. Dimensional folding techniques that had worked on smaller objects but created dangerous spatial distortions when scaled up. Molecular transmutation attempts that had turned portions of the crystal into gas before failing catastrophically. Time dilation fields that had successfully slowed the crystal's fall through time but had no effect on its physical weight. Lisa Hayes listened to each presentation with growing fascination. Not fascination with the technology, but with the fundamental approach each species was taking. Every solution involved adding more complexity, more energy, more advanced physics to overcome what was essentially a simple mechanical problem. When Director Vex Thanner called for new proposals, Lisa stood up. Her request seemed almost absurd in the context of the high-technology solutions that had just been presented. She wanted permission to conduct a geological survey of the canyon system, to study rock formations and structural integrity rather than quantum signatures or energy field interactions. The request prompted confused murmurs throughout the chamber. Dr. Zixandra's form flickered with what her translator interpreted as bewilderment. Engineer Prime Thokvar's optical sensors focused on Lisa with mechanical precision, clearly running calculations to determine what possible relevance rock composition could have to their problem. Master Engineer Velinox actually laughed. A sound that came through the translator as musical chimes. He asked, with what seemed like genuine curiosity, what studying stones could possibly accomplish that 3 years of advanced engineering had not. Lisa's answer was simple enough that every translation system in the room rendered it perfectly. Sometimes the best solutions were the oldest solutions. Before anyone could ask what she meant by that, Jake Morrison stood and requested permission to examine the canyon from a tactical perspective, treating it as terrain to be navigated rather than an obstacle to be overcome with technology. The permissions were granted with the kind of polite dismissal usually reserved for harmless but pointless activities. While the other species continued their debates about quantum coefficients and dimensional parameters, the human team took a shuttle down to the planet's surface. The canyon system was even more impressive in person than in the holographic displays. Walls of solid rock stretched 800 meters down, carved by ancient rivers that had long since dried up. The excavation site at the bottom looked tiny from the rim, though Lisa knew it was actually larger than a football field. Pete Collins immediately began what he called his walkabout, a thorough examination of every surface, ledge, and structural feature visible from the canyon rim. He carried simple tools, a hammer for testing rock hardness, measuring tape for calculating distances, and a notebook where he sketched everything by hand. Amy Rodriguez set up her equipment at various points along the rim, taking measurements. That had nothing to do with exotic physics. She calculated load distributions, stress tolerances, and friction coefficients using formulas that any first-year engineering student would recognize. Jake Morrison approached the canyon like a military problem. He identified potential anchor points, studied sight lines, and assessed the accessibility of various positions along the rim. His years of experience moving heavy equipment in difficult terrain told him things that apparently no advanced alien civilization had considered relevant while the humans worked. Alien observers gathered to watch. Dr. Zixandra floated nearby, her energy form pulsing with curiosity as she tried to understand what Amy's simple calculations could possibly reveal. that quantum analysis had missed. Several construct units followed Pete Collins, their sensors recording his every movement while their processors struggled to categorize his activities. The breakthrough came when Pete realized something that should have been obvious from the beginning. The canyon walls were not just obstacles to be overcome, they were resources to be utilized. The rock formations he was studying were not random geological features. They were potential anchor points for a mechanical advantage system, AMES. Calculations confirmed what Pete suspected. The canyon walls could support far more weight than anyone had assumed. More importantly, the planet's intense gravity that made the crystal so heavy also meant that any counterweight system would be proportionally more effective. Jake Morrison's tactical assessment revealed numerous positions where equipment could be placed safely and efficiently. The canyon's natural geography actually provided an ideal framework for a large-scale pulley system, if anyone had bothered to look at it from a mechanical rather than technological perspective. As the day progressed, the alien observers grew more confused rather than less. They watched Pete hammer pieces of rock to test their hardness and could not understand how this related to moving a 50-ton crystal. They observed Amy measuring angles with simple tools and wondered why she was not using quantum sensors to detect dimensional variations. The most confusion came when Jake Morrison began discussing load paths and mechanical advantage. The concept seemed revolutionary to species that had solved similar problems by building bigger power sources rather than using physics to multiply the force they already had. That evening, back on the orbital station, the human team spread their findings across the table in their quarters. Pete's hand-drawn sketches showed anchor points, pulley positions, and cable routes mapped across the entire canyon system. Amy's calculations demonstrated that a properly designed counterweight system could easily lift 50 tons using nothing more sophisticated than steel cables and aluminum pulleys. Jake Morrison's logistics plan showed how the entire system could be assembled using components that the new Frontier's fabrication systems could produce. No exotic materials, no advanced power sources, no quantum field generators. Just simple mechanical engineering principles applied on a large scale. The solution was so simple that it almost seemed insulting to the advanced civilizations that had struggled with the problem for 3 years. But as Amy pointed out while reviewing her calculations one final time, the best solutions usually were simple ones. Complex problems often had elegant answers if you were willing to step back and look at them from a different perspective. Lisa Hayes reviewed the geological data that had made everything possible. The canyon walls were solid bedrock, capable of supporting thousands of tons of stress when properly anchored. The rock composition provided excellent friction characteristics for cable systems. Even the canyon's shape, carved by ancient water flow, created natural channels where cables could run without interference. As she prepared her presentation for the next day's briefing, Lisa wondered how many other impossible. The morning briefing session buzzed with anticipation as Lisa Hayes prepared to present the human solution. The holographic projector displayed Pete Collins's hand-drawn sketches, a stark contrast to the complex three-dimensional models and quantum field diagrams that had dominated previous presentations. Director Vex Thanner studied the simple drawings with all 4 eyes. His expression unreadable, Lisa began her explanation with basic physics principles that every spacefaring civilization should have known, but had apparently forgotten in their rush toward advanced technology. Mechanical advantage, she explained, allowed a small force applied over a long distance to move a large weight over a shorter distance. The principle was as old as the leva and as reliable as gravity itself. Dr. Zixandra's energy form flickered with what the translator interpreted as confusion. She interrupted to ask about the quantum coefficient calculations and gravitational field modulation parameters that surely must be involved in such a system. Lisa patiently explained that no exotic physics were required, just properly positioned pulleys and carefully calculated counterweights. Engineer Prime Thokvar requested detailed specifications for the power systems that would drive such a massive mechanical apparatus. Pete Collins stood and pointed to a simple hand-crank winch, drawn in one corner of his sketch. The construct unit's optical sensors focused on the drawing with mechanical precision, clearly running calculations to understand how such a primitive device could generate sufficient force. Master Engineer Valinux expressed polite skepticism about the load-bearing capacity of simple steel cables. Amy Rodriguez responded with stress calculations that demonstrated how properly distributed cable systems could handle far more weight than the concentrated force applications the aliens had been attempting. Her math was basic enough that any engineering student could verify it, but apparently revolutionary to civilizations that had come to rely entirely on energy-based solutions. The debate continued for nearly 2 hours, with alien representatives raising increasingly technical objections to what was fundamentally a simple mechanical solution. The Luminor worried about molecular stress patterns in the cable materials. The construct questioned the precision tolerances required for proper pulley alignment. The Zephyrians insisted that anti-gravity assistance would improve efficiency. Jake Morrison finally ended the discussion by requesting permission to demonstrate the concept on a smaller scale. Within an hour, he had assembled a working model using materials from the station's general fabrication systems. A small crystal weighing 50 kilograms served as a test subject, with miniature pulleys and cables arranged according to Pete's scaled-down design. The demonstration took less than 10 minutes. The mechanical advantage system lifted the test crystal smoothly and steadily, using nothing more than human muscle power applied to a hand crank. The alien observers watched in fascination as the simple machine performed flawlessly, requiring no energy fields, no quantum calculations, and no exotic materials. Permission to proceed with the full-scale construction was granted with the kind of reluctant curiosity usually reserved for harmless experiments. Director Vex Thanner made it clear that the consortium expected the human attempt to fail like all the others, but the demonstration had been impressive enough to warrant a chance. The New Frontiers fabrication systems worked continuously for the next 72 hours, producing pulleys, cables, anchoring hardware, and mechanical components according to specifications that Pete refined hourly. The designs were so simple that the ship's computer required no advanced programming, just basic industrial fabrication routines that had remained unchanged for centuries. Jake Morrison coordinated the logistics of moving equipment from orbit to the planet's surface. The heavy gravity made every transport run more expensive and dangerous than normal, but the mechanical nature of their solution actually worked in their favor. Unlike delicate energy field generators or precision quantum devices, pulleys and cables were robust enough to survive rough handling during atmospheric entry. Amy Rodriguez supervised the cable manufacturing process, ensuring that each strand met the stress requirements her calculations had specified. The cables themselves were simple steel construction, nothing exotic or advanced. Their strength came from proper engineering rather than revolutionary materials science. Pete Collins spent his time on the planet's surface, marking anchor points and installation positions with spray paint and survey stakes. His work resembled ancient road construction more than advanced alien engineering, but every mark he made had been precisely calculated for optimal force, distribution, and mechanical efficiency. The alien observers followed the human construction efforts with growing bewilderment. Dr. Zixandra repeatedly requested scans of the cable materials, convinced that some form of molecular enhancement must be hidden within the simple steel strands. Her energy sensors detected nothing but ordinary metal alloy, a result she found deeply troubling. Engineer Prime Thokvar analyzed every pulley design, searching for concealed mechanisms or hidden power sources. The aluminum wheels spinning on simple bearings clearly violated his understanding of how mechanical systems should function under such extreme conditions. His processors ran continuous stress calculations, all of which confirmed that the human design should work exactly as advertised. Master Engineer Valinux offered repeatedly to enhance the system with anti-gravity fields or gravitational dampening technology. Each offer was politely declined by Pete Collins, who explained that adding complex technology would only introduce potential failure points. The Zephyrian engineer found this logic incomprehensible, having spent his entire career believing that more advanced technology was always superior to simpler. Alternatives: the anchor point installation required the most precision of any aspect of the construction. Jake Morrison's military background proved invaluable as his team drilled into solid rock and installed mounting hardware capable of handling tremendous stress loads. Each anchor point was tested to twice its expected load before being approved. For use, the counterweight platform took shape at the bottom of an adjacent canyon, positioned to provide maximum mechanical advantage without interfering with the excavation site. The platform itself was simple steel construction designed to hold the carefully calculated stones and debris that would serve as counterweight. Amy Rodriguez had determined that the optimal counterweight would be approximately 200 tons, distributed across a platform large enough to ensure stability during the lifting operation. The weight would come from excavated material already present at the dig site, making the solution self-contained and resource-efficient. The main pulley assembly required the most careful positioning of any component in the system. Pete Collins spent 2 full days surveying and resurveying the installation site, using simple tools to ensure that the massive pulley wheel would be perfectly aligned with both the crystal's position and the counterweight platform. The cable routing proved more complex than anticipated, but not for technical reasons. The canyon's natural geography provided excellent natural channels for the cables to follow, but coordinating the installation across such a large area required military-style logistics that Jake Morrison managed with practiced efficiency. As the construction neared completion, alien representatives began arriving from across the galaxy to witness the attempt. News of the human approach had spread through diplomatic channels, generating curiosity about a species that proposed to solve advanced engineering problems using ancient mechanical principles. The betting pools that formed among various alien delegations generally favored failure, though the odds improved slightly after observers witnessed the small-scale demonstration. Most species remained convinced that the problem required technological solutions beyond anything the humans could provide. Lisa Hayes documented every aspect of the construction process, knowing that success or failure would become a case study in problem-solving approaches. Her interviews with alien observers revealed genuine confusion about human methodology, with many representatives unable to understand why the humans refused offers of technological assistance. The final component to be installed was the control system, which consisted of nothing more sophisticated than a manually operated winch and a set of mechanical brakes. The simplicity of the controls prompted renewed offers of computer assistance and automated operation systems, all of which were politely declined. Pete Collins made his final inspection of the completed system as the sun set over Kepler 442b. Every cable connection had been tested, every pulley wheel checked for proper rotation, every anchor point verified for structural integrity. The mechanical advantage calculations had been reviewed and confirmed by 3 separate teams. The system was ready for operation, built entirely from simple materials using principles that had been known since humanity first discovered the leva and the wheel. Tomorrow would prove whether ancient engineering wisdom could succeed where advanced alien technology had failed for 3 years. Dawn on Kepler 442b brought clear skies and perfect conditions for the extraction attempt. The orbital station buzzed with activity as representatives from across the galaxy prepared to witness what many expected to be another expensive failure. Holographic broadcast networks had been established to carry the event live to 12 different star systems, making it the most widely observed archaeological operation in galactic history. Pete Collins stood at the main control station, a simple wooden platform that looked almost primitive compared to the sophisticated observation decks the aliens had constructed around the canyon rim. His control panel consisted of a manual winch, several mechanical brake levers, and a basic intercom system for coordinating with his team positioned at various anchor points throughout the canyon system. Amy Rodriguez moved between monitoring stations, checking cable tension readings on simple mechanical gauges that looked like something from humanity's industrial age. Her calculations had been double-checked and triple-checked, but the final test would come when 200 tons of counterweight attempted to lift 50 tons of crystalline artifact against more than twice Earth's normal gravity, Jake Morrison. Coordinated communications between the human team and the assembled alien observers. His military training had taught him the importance of clear protocols and backup plans, so every aspect of the operation had been rehearsed and contingency procedures established for any foreseeable problem. Lisa Hayes positioned herself near the main observation deck where she could document both the extraction attempt and the reactions of the alien representatives. Her xenarchaeology background had taught her that studying the observers was often as revealing as studying the primary event. Director Vex Thanner announced the beginning of the operation with formal ceremony, his forearms gesturing toward the canyon system where the human contraption stretched across nearly a kilometer of terrain. His translation device rendered his words in dozens of languages simultaneously, though the underlying tone of polite skepticism came through clearly in all of them. Dr. Zixandra of the Luminar had positioned multiple energy sensors around the human equipment, still convinced that some form of hidden technology must be responsible for the system's claimed capabilities. Her instruments detected nothing but ordinary electrical activity from the basic motors that would assist the manual winch operation. Engineer Prime Thokvar of the Construct Collective had assigned a full analysis team to monitor every aspect of the human system during operation. Their sensors recorded stress loads, mechanical efficiency ratios, and structural deformation patterns, all in an attempt to understand how such primitive technology could possibly succeed where their advanced machinery had failed. Master Engineer Velenux of the Zephyrians floated near the main pulley assembly, his anti-gravity belt allowing him to observe the massive wheel from multiple angles. He had spent the previous evening reviewing Amy Rodriguez's calculations, finding them mathematically sound but conceptually impossible. Simple mechanical advantage should not be sufficient to overcome the gravitational challenges that had defeated. Gravitational field manipulation technology? Pete? Collins began the operation with a series of system checks that looked more like ritual than engineering. He tested each brake manually, confirmed communication with all anchor point teams, and verified that the counterweight platform was properly loaded and balanced. The simplicity of his procedures contrasted sharply with the complex pre-operational sequences that had preceded every alien attempt. The signal to begin came as nothing more dramatic than Pete speaking into his handheld radio. No energy discharges, no exotic particle emissions, no gravitational field fluctuations. Just a human voice saying, "Begin counterweight release," in simple, clear English that the translation systems rendered into dozens of alien languages. The counterweight platform began its descent slowly and steadily, pulled downward by the planet's intense gravity. The massive steel cables stretched slightly under the enormous load, but remained well within their design tolerances. Simple mechanical gauges showed tension readings that matched Amy's predicted values exactly. At the bottom of the canyon, 800 meters below the surface, the crystalline artifact began to rise. The movement was barely perceptible at first, just a few centimeters of upward motion that might have been attributed to measurement error. But the motion continued, steady and relentless, as the properly engineered mechanical advantage system did exactly what basic physics said it should do. Dr. Zixandra's energy sensors recorded the event with growing confusion. The power requirements were minimal, just enough electricity to operate the winch motors that assisted the manual controls. No quantum field fluctuations, no dimensional distortions, no exotic energy signatures. The crystal was rising through nothing more than the application of force multiplied by mechanical advantage. Engineer Prime Thokvar's analysis team worked frantically to understand what they were observing. Their calculations confirmed that the system was operating exactly as human engineering principles predicted, but those principles contradicted everything the construct had learned about moving massive objects in high-gravity environments. Simple. Steel cables should not be capable of such performance. Master Engineer The Lennox found himself questioning fundamental assumptions about technology and engineering that had guided his entire career. The human system was undeniably working, lifting a 50-ton object with an efficiency that his most advanced anti-gravity generators had been unable to achieve. The fact that it accomplished this feat using mechanical principles older than spaceflight itself challenged everything he thought he knew about problem solving. The alien observers fell silent as the extraction continued hour after hour without incident. The human system operated with the steady reliability of a machine designed around principles that had been tested for millennia rather than invented yesterday. No dramatic failures, no catastrophic overloads, no mysterious malfunctions. Just the quiet efficiency of properly applied physics. Pete Collins monitored the operation from his simple control station, occasionally adjusting the winch speed or checking cable tensions, but mostly just watching his calculations prove themselves correct in real time. The system required no constant intervention, no complex adjustments, no expert technicians standing by to fix inevitable problems. It simply worked. Amy Rodriguez tracked the crystal's progress on a basic plotting board, marking its position every 30 minutes as it rose steadily toward the surface. Her predictions had been accurate to within centimeters, demonstrating that simple physics calculations were more reliable than the exotic modeling techniques the aliens had employed. Jake Morrison coordinated with spotters positioned throughout the canyon system, confirming that all cables remained properly aligned and all anchor points maintained structural integrity. His military experience had taught him that simple systems were more reliable than complex ones, a lesson that seemed to be proving itself dramatically. After 6 hours of steady operation, the crystalline artifact reached the canyon rim. The moment was almost anticlimactic after 3 years of failed attempts and mounting desperation. The crystal simply emerged from the depths like cargo being unloaded from a ship, supported by cables and mechanical systems that looked like museum pieces compared to the sophisticated technology that surrounded them. The alien representatives stared in silence at the crystal resting safely on the canyon rim. The object that had resisted every form of advanced technology the galaxy could deploy had been moved by pulleys, cables, and counterweights. The solution that had eluded the most brilliant minds of 12 civilizations had been accomplished by humans using engineering principles that predated space travel. Dr. Zixandra's energy form flickered rapidly as she struggled to process what she had witnessed. Her sensors had recorded every detail of the operation, confirming that no hidden technology or exotic physics had been involved. The humans had succeeded through nothing more than proper application of mechanical advantage, a concept so simple that her people had apparently forgotten it existed. Engineer Prime Thokvar requested immediate detailed scans of all human equipment, convinced that some form of advanced materials science must explain the system's success. The scans revealed nothing but ordinary steel, aluminum, and basic electrical components. The sophistication lay not in the materials but in their arrangement and application. Master Engineer Vilinux floated in stunned silence near the extracted crystal, his worldview fundamentally shaken by what he had observed. His people were masters of gravitational manipulation, capable of making moons dance in space, yet they had been defeated by a problem that simple mechanical engineering had solved in a single day. Lisa Hayes moved among the alien observers, documenting their reactions and recording their comments for her archaeological report. The extraction of the predecessor crystal was certainly significant, but the real discovery was the revelation that advanced civilizations could become so dependent on sophisticated technology that they forgot how to think simply. Pete Collins supervised the final shutdown of his mechanical system, ensuring that all components were properly secured and all cables safely stored. The news of humanity's success spread through galactic communication networks faster than the fastest starships could travel. Within hours of the crystal's extraction, diplomatic channels buzzed with requests for technical details, engineering specifications, and most importantly, explanations of how such a primitive approach had succeeded where advanced technology had failed. Lisa Hayes found herself appointed as the Galactic Archaeological Consortium's new Director of Applied Physics. Before the celebration dinner had ended, The appointment came despite protests from several species that she held degrees in archaeology and anthropology rather than advanced engineering. Her first official act was to establish mandatory courses in what the consortium bureaucracy insisted on calling primitive mechanical engineering principles. The crystalline artifact, now safely housed in research facilities on the orbital station, began yielding its secrets about predecessor faster-than-light technology within days of its extraction. The breakthrough came not from exotic analysis techniques but from simple X-ray crystallography, a method so basic that most advanced civilizations had abandoned it centuries ago in favor of quantum resonance scanning. Pete Collins became an overnight celebrity throughout 12-star systems, though he seemed genuinely puzzled by the attention his work received. His lectures on basic mechanical advantage in high-gravity environments were attended by engineers from the most technologically advanced species in known space, all eager to learn principles that human first-year students took for granted. The most requested presentation in Pete's speaking schedule was titled, "Why Simple Solutions Work Better Than Complex Ones," a concept that proved revolutionary to civilizations that had spent millennia assuming that more advanced technology was always superior to older approaches. His hand-drawn sketches became required study material at engineering academies across the galaxy. Amy Rodriguez found herself leading the development of new consortium protocols that required consideration of mechanical solutions before implementing high-technology approaches. Her Rodriguez principle stated that any engineering problem should first be approached using the simplest possible solution that met the requirements, with complexity added only when absolutely necessary. The principle met strong resistance from species that had built their entire technological infrastructure around sophisticated solutions to simple problems. The Construct Collective initially refused to implement protocols that seemed to advocate technological regression until they discovered that mechanical systems required far less maintenance and showed dramatically lower failure rates than their advanced alternatives. Jake Morrison's promotion to head consortium security operations came with specific responsibility for managing projects that combined human practical thinking with alien advanced technology. His first major assignment involved a construct request for assistance with a massive space construction project that their most advanced fabrication systems had been unable to complete. The project involved assembling a space station in a region of space where gravitational anomalies interfered with anti-gravity systems and energy-based construction techniques. The construct had spent 2 years trying to develop new technology to overcome the interference, while Jake's solution involved adapting traditional construction methods to work in zero-gravity using mechanical fasteners and cable systems. Dr. Zixandra of the Luminar underwent what her people called a philosophical recalibration. After witnessing the crystal extraction, she enrolled in the consortium's new mechanical engineering courses, becoming one of the first energy-based beings to learn how to operate manual tools and calculate stress loads. Using nothing but mathematics and observation, her transformation became symbolic of a broader change occurring throughout galactic civilization. Species that had forgotten the satisfaction of solving problems through understanding rather than overwhelming them with technology began rediscovering the elegance of simple solutions applied with wisdom and precision. Engineer Prime Thokvar requested reassignment to work directly with human engineering teams, despite the loss of status this represented within construct society. His mechanical precision, when combined with human intuitive problem-solving, proved incredibly effective at finding solutions that neither approach could achieve alone. The partnership between construct analytical capabilities and human practical thinking led to the development of hybrid systems that combined the reliability of mechanical solutions with the precision of automated control systems. These hybrid approaches began replacing purely technological solutions throughout construct space. Master Engineer Velenuk spent 6 months studying with P. Collins, learning to approach engineering problems from a mechanical perspective rather than relying exclusively on gravitational field manipulation. His final project involved designing a planetary terraforming system that used mechanical atmospheric processors instead of energy-based weather control systems. The terraforming project succeeded beyond all expectations, transforming a dead world into a garden planet using techniques that required no exotic materials and could be maintained by any civilization capable of basic manufacturing. The project became a model for sustainable planetary engineering throughout Zephyrian space. The establishment of the Human Applied Engineering Institute marked the beginning of what historians would later call the practical Renaissance. Students from across the galaxy came to learn what they initially called primitive engineering, but gradually came to understand as fundamental problem-solving wisdom. The Institute's curriculum covered everything from basic mechanical advantage to complex structural engineering, but all courses shared a common philosophy. Technology should serve the solution, not define it. The most elegant answer to any problem was usually the simplest one that worked reliably under all expected conditions. Lisa Hayes stood in her new office aboard the consortium's flagship research station, looking out at a view of Earth's moon through the massive viewport. Her desk held two items that symbolized the transformation occurring throughout galactic civilization. The first was a quantum computational matrix gifted by the Luminar, representing the pinnacle of advanced technology. The second was Pete Collins's original hand-drawn sketch of the pulley system that had solved the crystal extraction problem. The quantum matrix could process calculations involving billions of variables in microseconds, but the hand-drawn sketch had solved a problem that had stumped the galaxy's greatest minds for 3 years. The contrast was not lost on Lisa as she reviewed applications from alien students wanting to study at the Institute. The crystalline artifact secrets had indeed revolutionized galactic travel, leading to faster-than-light systems that were not only more efficient than previous technology, but also more reliable because they incorporated mechanical backup systems alongside quantum field generators. The predecessor technology worked best when combined with simple, robust engineering, rather than being implemented through pure energy manipulation. The real revolution, however, was philosophical rather than technological. An entire galaxy of advanced civilizations had rediscovered the power of practical thinking, the wisdom of understanding problems before trying to solve them, and the revolutionary concept that effective solutions did not always require the most advanced technology available. Jake Morrison's security teams began receiving requests from species throughout the galaxy asking for assistance with problems that their own advanced technology could not solve. Each successful project reinforced the growing understanding that human approaches to problem-solving offered something that pure technological advancement could not provide. Pete Collins opened a consulting firm that specialized in what he called appropriate technology solutions, helping alien civilizations find mechanical answers to problems they had been trying to solve through increasingly complex technological approaches. His first major contract involved helping the Luminar build physical infrastructure that their energy-based society had never needed before. Amy Rodriguez published a series of papers on fundamental engineering principles for advanced civilizations that became required reading at technical academies throughout known space. Her work demonstrated that mathematical relationships and physical laws remained constant regardless of technological sophistication, and that understanding these fundamentals was more valuable than mastering any specific advanced technology. The transformation was not without resistance. Conservative factions within several species argued that adopting primitive human methods represented technological regression rather than progress. These arguments lost credibility as human-assisted projects consistently succeeded where traditional approaches had failed. Lisa Hayes reflected on the irony of the situation as she prepared her annual report to the Consortium Council. Humanity had joined galactic civilization as one of its least technologically advanced members, bringing nothing but curiosity, practical thinking, and a willingness to question assumptions that other species had accepted without examination. The report she was writing would document how these simple qualities had transformed not just archaeological practices but engineering approaches throughout the galaxy.